Hey guys, good morning. So we're in Ocean, Atmosphere, and Climates, lesson 1.3. Our dinner for today is to look carefully at the graph and read all the information to review how the temperature of Christchurch, New Zealand changes during an El Nino year. And then you're going to answer the question below. So if we look during a normal year, it has a temperature of 2, 4, 6, 8, 10, 12 degrees Celsius. And then during the El Nino year, it has a temperature of 11 degrees Celsius. So El Nino events occur every 2 to 7 years. There's a shift in the climate across the tropical Pacific, which causes some areas to be colder than usual and some areas to be warmer than usual. Christchurch, New Zealand air temperature is cooler than usual during El Nino years. This means that the air has blank energy during El Nino events. So on Amplify, you're going to answer this question with either more or less energy. So you're going to tell me whether the air has more or less energy during El Nino year. So we know that air temperature is determined by the amount of energy in the air. But today we'll investigate how does that air get its energy. So just a quick vocabulary review. We learned the word transfer. We learned it in our thermal energy unit, and we kind of been using it ever since. So just a quick review, transfer is to move from one object to another or one place to another. So when we ask about how it gets energy, we really want to know how energy is transferred to the air. So let's look at this diagram. So there are two claims about how does air get its energy, or how this energy is transferred. So claim 1 says energy is transferred from the sun to the air. So it's transferred directly from the sun to the air. Claim 2 says energy is transferred from the sun to the surface, and the surface could be land or water, and then from the surface to the air. Right? So there's a little bit of difference here. One saying that the air is directly getting energy from the sun, and the other one says energy is transferred from the sun, then to the surface, from the surface to the air. So we're going to do a quick experiment to see what this looks like. We're going to explore this. And the way that we're going to do it is with this heating experiment set up. So we're going to have a lamp, which shows us our energy from the sun. We're going to have air, of course, with no surface. And we're going to have some rocks. These rocks, we're going to represent both land and water. Right? And this air here is going to represent the air right above the surface. So we're going to watch a quick video of Miss Jackson demonstrating this. Okay guys, so we are in Ocean, Atmosphere, and Climates. We're in lesson 1.3, and I'm going to be demonstrating to you the difference in temperature when we look at air above the Earth's surface and air higher. So this cup 1 is our air above the rocks. You're going to record that in your data table. And this cup 2 is air over no surface. So let's start with taking our initial temperatures. So the initial temperature of this is about 23 degrees Celsius, and our initial temperature of this is about 23 as well. We're going to turn on the lamp to simulate the sunlight, and we'll see what happens. I'm going to check back in 20 minutes. Okay, so let's make some predictions. So if I was looking at claims, we have two claims here, right? And claim 1 is that air is being directly heated, right, from the sun. So the energy is transferring from the sun to the air. And claim 2 is saying air is transferred from the sun to the surface to the air. So I'm going to let's do a quick poll. Who thinks claim 1? Who thinks claim 2? Click on which one you think. All right. So if claim 1, for example, was true, would we expect the air temperature where there's no surface underneath to be higher, lower, or the same as the air above rocks? I want you guys to think about that for a second. Yeah, those two air temperatures would be the same. And if claim 2 was correct, would we expect the air temperature to be, where there's no surface, would we expect that to be higher, lower, or the same as the air above the rocks? That's right, it would be lower because there's no surface to heat our air. Okay, so we are going to, well, Miss Jackson's going to pause and she's going to show you what this looks like. So you're going to watch a quick video. Before we play this video though, I do want you to know that we're putting on this information in Amplify. So if I click on this amplifier right here, we have handed in, so you would have completed and handed in your warm-up. We are now going to our teacher-led discussion. We're on part 2. Ms. Jackson reviewed what transfer is. And we kind of made our predictions, and we know what's going to happen if claim 1 is right, and we know what's going to happen if claim 2 is right? If claim 1 is right, then both air temperatures at the end will be the same. And if claim 2 is right, then the air temperature with no surface underneath would be lower than the one with rocks underneath. So let's look and view what happens. As I conduct this experiment, you are going to write your answers right here on 3 under number 2. So you have your temperature, your starting temperature, which we have already recorded, and you'll have your final temperature and a change in air temperature. For those of you who need a refresher of what that looks like, our starting temperatures were 23 degrees Celsius. So as you watch this video, I want you to fill in your final air temperature and your change in air temperature. So you're going to fill in those 2 boxes on Amplify. Okay, so tune into the video. Okay, y'all, so it's been 20 minutes. Let's record the temperature above the rocks and the temperature above the air. So the temperature of the air over here is hold up. Still at 23, right? That's our cup 2, air surface no temperature. And let's look over here with our rocks. This temperature is at 25 degrees Celsius. So remember, the original temperatures were, let me not break this off, 23 degrees Celsius. Our air with no surface underneath is still that same 23 degrees Celsius. However, our final air temperature over here is 25 degrees Celsius. So you're going to do your changes in air temperature. Here's a little hint. This one's 0. All right. Have a good rest of the lesson. Okay, welcome back again. So at this time, this should be completely filled out for you guys. And you should have hit the hand in button right here. Please make sure you hand in your work so I can see it. And now we're going to, before we move on to our simulation, we are going to look at our data and do some discussion. So there are 3 questions here that we want to answer. One is, what happened in our experiment? 2 is, do the results support claim 1 and claim 2? And the third thing we're going to discuss is, what might we have learned from this experiment and how might it help us answer the question, how does air get energy? So here, I'm going to come over here Once again, I have stolen somebody's login. So Miss Jackson has it here too on our discussion. We're gonna what happened to the experiment, do the results support claim 1 or claim 2, and what did you learn from the experiment? So we all saw that during the experiment, we saw the air above the rocks. Oh, Miss Jackson has a typo. Get hotter than without surface, right? And we know that that means that more energy was transferred, right? So energy was transferred. And where did the energy transfer from? That's right, from above, from the surface to the air. Boom. So does my results support claim 1 or claim 2? Well, let's look back. Claim 1 said energy was transferred from the sun to the air. And we saw that that was not true. So it's going to support claim 2. So in my discussion, I'm going to write this supports claim. And because you guys haven't seen this yet, I'll just put it. It's fine. Claim 2. Because that was the only temperature that increased. Right? The only temperature that increased was the one over the rocks. What did I learn in this experiment that might help me answer the question, how does air get energy? Well, I learned that energy has to be transferred from, and I'll let you guys finish that sentence, right? And then I'm going to turn it in. So this is what your discussion should look at after you do it. Please remember to turn it in so you can get your points. Notice now it says see classmates' answers. So when you see your classmates' answers, I'm the only one who answered right now, but if somebody else answered, you'd be able to reply to them. So remember that you get your full points by not only answering the question, but also commenting on a peer's response. That's the only way you're going to get all 100 points. So now that we've checked off our discussion, we got something done today. Boom, boom. We already got 100 points in the bag for today. So we are back at slide 8, where we were looking at the discussion questions. So now it's time for the simulation, and it tells us to go to Amplify. So let's look at what's going over here with Amplify. Ms. Jackson's going to click on the sim page. Okay, so we're going to gather evidence with the simulation. So remember, our investigation question is, how does air get energy? And we think that energy can either be transferred from the sun to the air, or energy can be transferred from the sun to the surface to the air. So now we really want to see what's happening with our second experiment. We're really trying to figure out if what we saw in the last experiment is true all the way around. The first thing we're going to do is predict what will happen to the air temperature, right, with surface and no surface. So I predict that the air temperature will, and you're going to choose increase, decrease, stay the same, right? With the surface, I don't know. Maybe I'm going to say the temperature will increase. Maybe I think it decreases. It could possibly stay the same, right? With no surface, I predict the air temperature will, and it's the same options. Increase, decrease, stay the same. So you're going to choose your predictions. And then notice how it said hand in. Make sure you hit the hand in button. Okay. And then I'm going to scroll down. So now it tells us to open the simulation and go to surface test mode. So Ms. Jackson already opened the sim in another tab, but for those of you who don't remember, it's the little 3 lines to the left, and then you're going to hit oceans, atmospheres, and climates. Right, the 3 lines here. Put on that page. So it tells me to change it to surface test mode. So I'm going to hit these 3 lines, and I'm going to change it to surface test. And I'm going to hit yes. For both of these experiments where I'm running it, notice how I'm going to keep my temperature at medium. And the reason why I'm going to keep this temperature at medium is because I want to make sure that I'm getting fair results. So I want to compare the same things. So I'm running this for a minute. And I'm going to see what happens. So we should have noticed, and I'll refresh it for anybody who didn't see, we should have noticed that our temperature, our air temperature starts off really low. Right? And we can see our water temperature is increasing and it's higher than our air temperature. Our land temperature is increasing and it's higher than our air temperature because the energy is going from the sun to the surface. And then, as I look, we're about to reach that magic number, right? We know equilibrium is where our temperatures are the same. So let's see. I'm going to wait for this to stop. All right. And if I'm noticing, right, I'm seeing that my air temperature increased. It went from -10 to about 22 degrees Celsius, right? And notice how all my temperatures are now stable. So I ran that for a minute. So now let's look at if we had no surface. And let's run it if it has no surface. So I'm going to hit the refresh button. Yes. And then, oh, sorry, Ms. Jackson said no surface. And as we can see, my air temperature stays at that -10 degrees Celsius. I'll let it sit here for a little bit longer, but we can see there's no change in our temperature. All right, so now I'm going to go back here and I'm going to say after 1 minute, the air temperature, and you're going to tell me what happened. We just watched it together. If you're unsure, please run it back again and play with the simulation yourself. That's half of the fun. And with no surface, the air temperature did what? And we can just have a look back at that. So you're going to tell me what happened there. And then remember, you need to put your answers. So Ms. Jackson's just going to hit a random answer. Just so you can see, you have to hit the hand in button. And that's how I see your work. Boom. So we're now knocked out most of our work. So now we just have to do our student-to-student discussion. So let's go to our student-to-student discussion. We've already completed this first part here on Google Classroom. So boom, if you completed this here, you're already done. You already got some points in the bucket. Perfect. So now let's hit next. So we're going to revisit our claim. You're going to choose which claim do you think is best supported by evidence, claim 1 or claim 2. And you're going to tell me what evidence supports the claim. So you can either use the sim, you can use the experiment we watched. You're going to make sure you answer all of that. And then you're going to hit the hand in button. Once again, one thing I want everybody to leave here knowing, though, is that energy from the sun is transferred to the Earth's surface, and then some of that energy is then transferred to the air above the Earth. So we need to know that the energy from the sun is transferred to the Earth's surface, and then that some of that energy is then transferred to the air above the surface. So we're not going to see this transfer of energy if we didn't have the surface there. So now that we've done all that, last thing for you to do is your homework. And your homework is quick and easy today. So it says read the statement and determine if you agree or disagree and use evidence to support your answer. So the question is, the sun warms air directly. So you're going to say, I agree the sun warms air directly. I disagree. Right? You're going to write whatever you say. Miss Jackson is going to hit random letters so that you can see. And then you're going to use evidence. We looked at the simulation. We looked at the experiment, and then you're going to make sure you hit the hand in button, and you are all done for today. All right, looking forward to seeing your answers. See you tomorrow.